Dear students, welcome to the online chemistry classes organized by the Mysuru District PU Chemistry Lecturers Forum. Let me introduce myself. My name is Chaitra P, lecturer in chemistry, B.G.S PU College, Mysuru. Students, you are watching my PU Chemistry YouTube channel. Please subscribe the channel to get the regular updates. Let us start today's session with the topic Hess's law of constant heat summation, one of the important topic in the chapter thermodynamics. So, here in the Hess's law, first let us take what is enthalpy. So, here we know that enthalpy means it is the sum of internal energy and the product of pressure and volume. Sum of internal energy and the product of pressure and volume. Internal energy U and this is P pressure and this is volume. H is equal to U plus PV, where H is the enthalpy. And enthalpy is one of the state function. We know that enthalpy is one of the state function. So, state function means what is that? It depends on the initial state of the system and final state of the system, but not on the path. So, it depends on the initial state, like the reactants. Initial state of the system, it depends on the initial state of the system and the final state of the system. Final state of the system, that is reactants get converted into products but not on the path, does not depends on the path. So, that is why enthalpy is a state function. In other words, enthalpy change is same whether the reaction is carried out in one step or in a series of steps. What is that? Enthalpy change is same whether the reaction is carried out in one step or a series of steps. Okay, let us write down that. Enthalpy change or change in enthalpy. Enthalpy change is same whether a reaction is carried out in one step or in a series of steps ಅಂದರೆ ಒಂದು ರಿಯಾಕ್ಷನಲ್ಲಿ ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ನಮಗೆ ಗೊತ್ತಿದೆ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಗೆಟ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಪ್ರಾಡಕ್ಟ್ಸ್ ಮೀನ್ಸ್ ಡೆಫಿನೆಟ್ಲಿ ಎಂಥಾಲ್ಪಿ ಚೇಂಜಸ್. ಸೊ ಆ ರೀತಿ ಚೇಂಜ್ ಆಗಬೇಕಾದ್ರೆ ಒಂದು ರಿಯಾಕ್ಷನು ಒಂದು ಸ್ಟೆಪ್ಪಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆಗಿರುವಂಥ ಎಂಥಾಲ್ಪಿ ಚೇಂಜು ಮತ್ತು ಸಪೋಸ್ ಅದೇ ರಿಯಾಕ್ಷನ್ನು ನಿಮಗೆ ಸೀರೀಸ್ ಆಫ್ ಸ್ಟೆಪ್ಸಲ್ಲಿ ಚೇಂಜ್ ಆಗಿದ್ರೆ ಕೂಡ ಸೊ ಎರಡರಲ್ಲೂ ಕೂಡ ಎಂಥಾಲ್ಪಿ ಚೇಂಜು ಒಂದೇ ಇರುತ್ತೆ. ಸೊ ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಇಸ್ ಸೇಮ್ ವೆದರ್ ಅ ರಿಯಾಕ್ಷನ್ ಈಸ್ ಕ್ಯಾರಿಡ್ ಔಟ್ ಇನ್ ಒನ್ ಸ್ಟೆಪ್ or in a series of steps. So, here let us consider one of the example now. Let us consider one of the example like carbon, that is C, that is graphite. Carbon is in the graphite form and we know that which is in a solid form, S represents that solid. When this carbon burns in the presence of oxygen, it give rise to carbon monoxide. Oxygen is also in a gaseous form and carbon monoxide is also in a gaseous form. Carbon burns in the presence of oxygen, give rise to carbon monoxide. and during this reaction, what is the enthalpy change? What is the enthalpy change of this reaction? And in this reaction, the major product is carbon monoxide. But along with that carbon monoxide, some amount of carbon dioxide also produced. In this reaction, carbon monoxide is the major product, but along with that, some amount of carbon dioxide also produced. So, in order to calculate the enthalpy of this reaction, so by using this reaction, it is not possible to calculate the enthalpy of reaction because along with that carbon monoxide, some carbon dioxide also produced. So, that is why we are using indirect method to calculate the enthalpy of this reaction. Indirect method means we are going to consider some of the reactions now. What are those reactions? Let us consider the reaction that is carbon which is in a solid form. When it combines with the oxygen, when it combines with oxygen, it gives rise to carbon dioxide. When carbon, which is in a solid form, bonds with oxygen, give rise to carbon dioxide, and enthalpy of this reaction is minus 393.5 kilojoule per mole. Minus 393.5 kilojoule per mole. And similarly, let us consider one more reaction, that is carbon monoxide bonds with oxygen, that is carbon monoxide is in a gaseous form, oxygen is also in a gaseous form, and it gives rise to carbon dioxide which is in a gaseous form, where enthalpy change for this reaction is minus 283 kilojoule per mole. Minus 283 kilojoule per mole. See, here we have considered two reactions. One is carbon to carbon dioxide and another one is carbon monoxide to carbon dioxide. Which is the required equation? Required equation ಅಂತಂದ್ರೆ ನಾವು ಯಾವುದಕ್ಕೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಎಂಥಾಲ್ಪಿ ಆಫ್ ರಿಯಾಕ್ಷನ್? ಕಾರ್ಬನ್ ಟು ಕಾರ್ಬನ್ monoxide. Look at the equation now, and let us call this equation as 1 and let us call this equation as 2, and in the equation 2 we have carbon monoxide. ನಮ್ಮ ಹತ್ರ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಇದೆ, ಬಟ್ ರಿಕ್ವೈರ್ಡ್ ಇಕ್ವೇಷನ್ ಅಲ್ಲಿ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಎಲ್ಲಿದೆ? ಪ್ರಾಡಕ್ಟ್ ಸೈಡಲ್ಲಿ ಇದೆ ಅಲ್ವಾ? ನಮಗೆ ಇರೋಂಥ ರಿಯಾಕ್ಷನಲ್ಲಿ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್. ನಮ್ಮ ಹತ್ರ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡಲ್ಲಿದೆ. ನಮಗೆ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡು ಪ್ರಾಡಕ್ಟ್ ಸೈಡಲ್ಲಿ ಬೇಕು. ಸೊ ಪ್ರಾಡಕ್ಟ್ ಸೈಡಲ್ಲಿ ಬೇಕು ಅಂದರೆ ಏನು ಮಾಡಬೇಕು? ಲೆಟ್ ಅಸ್ ರಿವರ್ಸ್ ದ ಸೆಕೆಂಡ್ ಇಕ್ವೇಷನ್. ಈ ರಿಯಾಕ್ಷನ್ ಏನು ಮಾಡ್ಕೊಳ್ಳೋಣ ನಾವು? ರಿವರ್ಸ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಸೊ ನೆಕ್ಸ್ಟ್ ಲೆಟ್ ಅಸ್ ರಿವರ್ಸ್ equation 2 now. Let us reverse equation 2. So if you reverse this equation, what you are going to get? ಏನು ಬರುತ್ತೆ? Carbon dioxide which is in a gaseous form. Okay, we are reversing this equation. So carbon monoxide gas plus half O2, that is in a gaseous form, where enthalpy change for this reaction, here the value is minus 283 kilojoules. So, but we are reversing this reaction means we can write this as a positive, plus 283 kilojoules per mole, plus 283 kilojoules per mole, and let us call this equation as 3. So now we have carbon monoxide in the ಪ್ರಾಡಕ್ಟ್ ಸೈಡ್. ನಮಗೆ ಬಂತು, ಪ್ರಾಡಕ್ಟ್ ಸೈಡಿಗೆ ಬಂತು. ಇನ್ನೊಂದು ಕಾರ್ಬನ್ ಸಾಲಿಡ್ ಫಾರಮಲ್ಲಿರುವಂಥ ಕಾರ್ಬನ್ನು ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡಲ್ಲಿ ಬೇಕು. ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡು ಪ್ರಾಡಕ್ಟ್ ಸೈಡಲ್ಲಿ ಬೇಕು. ಸೊ ಕಾರ್ಬನ್ ಸಾಲಿಡ್ ಫಾರಮಲ್ಲಿ ಇರುವಂಥದ್ದು ಫಸ್ಟ್ ಈಕ್ವೇಷನಲ್ಲಿದೆ, ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡು ನಮಗೆ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮೇಷನಲ್ಲಿರೋದು ಥರ್ಡ್ ಈಕ್ವೇಷನಲ್ಲಿದೆ. ಸೊ ಬೈ ಕಂಬೈನಿಂಗ್ ಈಕ್ವೇಷನ್ 1 and 3, ಸೊ ಇಫ್ ಯು ಕಂಬೈನ್ ದ ಈಕ್ವೇಷನ್ 1 and 3 ಕಂಬೈನ್ ಮಾಡಿದ್ರೆ, ಸೊ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ದಿಸ್ ಈಕ್ವೇಷನ್. ಸೊ ಲೆಟ್ us combine that equation because we are going to calculate the enthalpy of this reaction. Okay, in the next step, let us combine equation 1 and 3. We are combining the equation 1 and 3. So equation 1 is carbon, which is in a solid form. When it combines with oxygen, it gives rise to carbon dioxide, where the enthalpy of this reaction is minus 393.5 kilojoule per mole. This is the first equation. And the third equation is, so the third equation is carbon dioxide, which is in a gaseous form, and it gives rise to carbon monoxide plus half O2 plus half O2, where enthalpy of reaction is plus 283 kilojoule per mole. And if you combine these two equations, so here we can cancel out carbon dioxide and the carbon dioxide, because carbon dioxide present in the reactant side as well as in the product side. So we can cancel out, and we are having half O2, and this is 1 O2, 1 mole of oxygen, 1 O2. 1 minus half means you are going to get half O2. So we can write this as ಇಲ್ಲಿ half ಉಳ್ಕೊಂಡಿದೆ. We can write this as carbon plus half O2 plus half O2 give rise to carbon monoxide. See, we are getting the same equation. Carbon plus half O2 give rise to carbon monoxide. And what is the enthalpy of this reaction? Let us combine these two now. That is minus 393.5 and plus 283.0, and you are going to get minus 110.5 kilojoule per mole. So enthalpy of this reaction is minus 110.5 kilojoule per mole. So indirectly we have calculated enthalpy of reaction of carbon monoxide by considering the two equations. So what are the two equations we have considered here? Carbon combines with oxygen give rise to carbon dioxide, and another reaction is carbon monoxide plus half O2 give rise to carbon dioxide. But in order to get the required equation, we have reversed this equation. So if you reverse this equation, that negative sign is get converted into a positive sign. We know that minus 283 changes into plus 283. And if you combine equation 1 and 3, you are going to get the required equation. So what is the enthalpy of reaction here? Minus 110.5 kilojoule per mole. Okay, here by using the Hess's law, we have calculated enthalpy of reaction of the conversion of the reaction, that is carbon to carbon monoxide. Okay, similarly, let us consider one more reaction. Let us consider one more reaction, that is carbon changes into carbon dioxide. Let us apply this statement now. What is that statement of Hess's law? Enthalpy change is same whether a reaction is carried out in one step or in a series of steps. Enthalpy change is same. So, let us consider the reaction now. Carbon, which is in a solid form, when combines with oxygen, that is in a gaseous form, converted into carbon dioxide. Converted into carbon dioxide, where the enthalpy of this reaction is minus 393.5 kilojoule per mole. Kilojoule per mole. So, here reaction in one step, conversion of carbon to carbon dioxide. But the reaction also takes place in series of steps. So, here let us consider another reaction, like carbon combines with oxygen, half O2, and it get converted into carbon monoxide, which is in a gaseous form. What is the enthalpy of this reaction? So, here only we have the same reaction, carbon with oxygen, carbon monoxide. What is the enthalpy of this reaction? Minus 110.5. So, the enthalpy of the reaction is 110.5 kilojoule per mole, minus 110.5 kilojoule per mole. And the formed carbon monoxide combines with excess amount of oxygen, and it get converted into carbon dioxide. It get converted into carbon dioxide, and for this enthalpy of the reaction is minus 283 kilojoule per mole. This is the single step reaction. Carbon combines with oxygen, give rise to carbon dioxide. But the reaction proceeds in two intermediate steps, two intermediate reactions, like at first carbon converted into carbon monoxide, then carbon monoxide changes into carbon dioxide. ಇಲ್ಲಿ ಒಂದೇ ಸ್ಟೆಪ್ಪಲ್ಲಿ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿದೆ. ಅದೇ ರಿಯಾಕ್ಷನ್ನು ಎರಡು ಸ್ಟೆಪ್ಪಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಆಯಿತಾ, ಎರಡು ಸ್ಟೆಪ್ಪಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆಗೋದು ಅಂತಂದರೆ, ಈಗ ಸ್ಟೆಪ್ 1 ಅಂತ ತೊಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ, ಫಸ್ಟು ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಆಗಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. ವಾಟ್ ಈಸ್ ದ ಎಂಥಾಲ್ಪಿ ಆಫ್ ದಿಸ್ ರಿಯಾಕ್ಷನ್? 110.5 minus 110.5 ಕಿಲೋಜೌಲ್ ಪರ್ ಮೋಲ್ ಅಲ್ಲಪ್ಪ. ನೆಕ್ಸ್ಟು ಅದೇ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡು ಮತ್ತು ಆಕ್ಸಿಜನ್ ಜೊತೆ ಕಂಬೈನ್ ಆಗಿ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಚೇಂಜ್ ಆಗುವಂಥ ಎಂಥಾಲ್ಪಿ minus 283 kilojule per mole. And this is the step 2. ಇದನ್ನು step 2 ಅಂತ ತಗೊಳ್ಳೋಣ ಬೇಕಾದರೆ. And if you combine these two reactions, ಏನು ಬರುತ್ತೆ? If you combine these two reactions, so here we can cancel out carbon monoxide and carbon monoxide ಅಲ್ವಾ? ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೋಬೋದು. ಇನ್ನೇನಾದರೂ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತಾ? ಇಲ್ಲ, ಕ್ಯಾನ್ಸಲ್ ಆಗಲ್ಲ. ಈಗ ಬರೀತಾ ಹೋಗೋಣ. ಯಾವುದು? ಕಾರ್ಬನ್ ವಿಚ್ ಇಸ್ ಇನ್ ಎ ಸಾಲಿಡ್ ಫಾರಮ್ ಪ್ಲಸ್ ಹಾಫ್ O2 ಹಾಫ್ O2, ಹಾಫ್ ಪ್ಲಸ್ ಹಾಫ್ ಅಂತಂದ್ರೆ ಎಷ್ಟು? 1. ದಟ್ ಮೀನ್ಸ್ O2 ಗ್ಯಾಸ್. ಆ್ಯಂಡ್ ಇಟ್ ಗಿವ್ ರೈಸ್ ಟು ಏನು ಬರ್ತಾ ಇದೆ? ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಅಂತಂದರೆ ಗೇಷಿಯಸ್ ಫಾರಮಲ್ಲಿ ಇದೆ. ಸೊ ಇವಾಗ ಎರಡು ಕಂಬೈನ್ ಮಾಡಿದ್ದೀವಿ ಅಂತ ತಕ್ಷಣ ಲೆಟ್ ಅಸ್ ಕಂಬೈನ್ ದೀಸ್ ಟು ಆಲ್ಸೋ. that is minus 110.5 and here minus 283. If you combine these two, you are going to get 393.5 kilojoule per mole. Minus 393.5 kilojoule per mole. Look at the value now. What is the value we are getting? Minus 393.5. Single step alli ಏನು ಬರ್ತಾ ಇತ್ತು ವ್ಯಾಲ್ಯೂ? ಮೈನಸ್ 393.5 ಅಲ್ವಾ? ಅಂತಂದರೆ change in enthalpy or enthalpy change is same whether a reaction is carried out in one step or in series of steps. ಒಂದೇ ಸ್ಟೆಪ್ಪಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆದಾಗ ಏನು ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಆಗಿರುತ್ತೋ ಅದೇ ರಿಯಾಕ್ಷನ್ನು ಸೀರೀಸ್ ಆಫ್ ಸ್ಟೆಪ್ಪಲ್ಲಿ ಚೇಂಜ್ ಆದರೂ ಕೂಡ ನಿಮಗೆ ಅಷ್ಟೇ ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಇರುತ್ತೆ. ಇವಾಗ 1 ಸ್ಟೆಪ್ಪು 2 ಸ್ಟೆಪ್ಪು 3 ಸ್ಟೆಪ್ಸಲ್ಲಿ ಆ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಅಂದ್ಬಿಟ್ಟು ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಇನ್ ಎಂಥಾಲ್ಪಿ ಡಿಫ್ರೆಂಟ್ ಬರಲ್ಲ, ನಿಮಗೆ ಒಂದೇ ಎಂಥಾಲ್ಪಿ ಬರುತ್ತೆ. ದಟ್ ಲಾ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಎ ಹೆಸ್ಸಸ್ ಲಾ ಆಫ್ ಕಾನ್ಸ್ಟ್ಯಾಂಟ್ ಹೀಟ್ ಸಮೇಷನ್ ಅಲ್ಲಪ್ಪ. ಅಂತಂದರೆ ಇವಾಗ ನೋಡಿ ಇಲ್ಲಿ ಒಂದೇ ಸ್ಟೆಪ್ಪಲ್ಲಿ ಎಷ್ಟು ಬರ್ತಾ ಇತ್ತು ವ್ಯಾಲ್ಯೂ? ಮೈನಸ್ 393.5 ಕಿಲೋ ಜೌಲ್ಸ್ ಬಂತು. ಈಗ ಅದೇ ರಿಯಾಕ್ಷನ್ನು 2 ಸ್ಟೆಪ್ಪಲ್ಲಿ ಆಗ್ತಾ ಇದೆ ಆಯಿತಾ? 2 ಸ್ಟೆಪ್ಪಲ್ಲಿ ಮಾಡ್ಕೊಂಡ್ವಿ, ಕಂಬೈನ್ ಮಾಡಿದ್ವಿ, ನಮಗೆ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ದ ಸೇಮ್ ಇಕ್ವೇಷನ್. ನಮ್ಗೆ ಅದೇ ಇಕ್ವೇಷನ್ ಬರ್ತಾ ಇದೆ ಇಲ್ಲೂ ಕೂಡ, ಮತ್ತು ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಕೂಡ ಒಂದೇ ಬರ್ತಾ ಇದೆ. ದಟ್ ಈಸ್ ಮೈನಸ್ 393.5 ಕಿಲೋ ಜೌಲ್ ಪರ್ ಮೋಲ್. Okay, this is the statement of Hess's law of constant heat summation, and we can explain that Hess's law by using this example. ಈ ಎಕ್ಸಾಂಪಲ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವೇನು ಮಾಡ್ಬೋದು? Hess's lawನ ಕರೆಕ್ಟಾಗಿ ನಾವು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಕೋಬೋದು. ಸೊ ಇದೇ Hess's lawನಲ್ಲಿ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಒನ್ ಜನರಲ್ ರಿಯಾಕ್ಷನ್. ಇವಾಗ ಗೊತ್ತಾಯಿತು ನಿಮಗೆ, ಒಂದು ಸ್ಟೆಪ್ಪಲ್ಲಿ ಏನು ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಆಗಿರುತ್ತೋ ಅದು ಸೇಮ್ ಇರುತ್ತೆ. ಸಪೋಸ್ ಅದೇ ರಿಯಾಕ್ಷನ್ನು ನಿಮಗೆ ಸೀರೀಸ್ ಆಫ್ ಸ್ಟೆಪ್ಸಲ್ಲಿ ಸೆವರಲ್ ಸ್ಟೆಪ್ಸಲ್ಲಿ ಚೇಂಜ್ ಆದರೂ ಕೂಡ ಎಂಥಾಲ್ಪಿ ಚೇಂಜು ಸೇಮ್ ಇರುತ್ತೆ. ಆ ಲಾನ ಏನಂತ ಕರೆದ್ವಿ ನಾವು? ಹೆಸ್ಸಸ್ ಲಾ ಆಫ್ ಕಾನ್ಸ್ಟ್ಯಾಂಟ್ ಹೀಟ್ ಸಮೇಷನ್ ಅಂತ ಕರೆದ್ವಿ. ಸೊ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಒನ್ ಮೋರ್ ಎಕ್ಸಾಂಪಲ್ನ. ಈಗ ಇನ್ನೂ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. Okay, let us consider one more example. ಏನಪ್ಪ ಅದು ಎಕ್ಸಾಂಪಲ್ ಇನ್ನೊಂದು? ದಟ್ ಈಸ್ ಎ ಒನ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ ಆ್ಯಂಡ್ ಇಟ್ ಗೆಟ್ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಟು ಬಿ. ಒಂದು ಜನರಲ್ ಆಗಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ತಾ ಇದ್ದೀವಿ. ಎ ಈಸ್ ಗೆಟ್ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಟು ಬಿ. ವಾಟ್ ಈಸ್ ದ ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಹಿಯರ್? ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಫಾರ್ ದಿಸ್ ರಿಯಾಕ್ಷನ್, ಲೆಟ್ ಅಸ್ ಟೇಕ್ ಇಟ್ ಆಸ್ ಎ ಡೆಲ್ಟಾ ಎಚ್ ಅಂತ ತಗೊಳ್ತಾ ಇದ್ದೀವಿ. ಅದೇ ರಿಯಾಕ್ಷನ್ನು, ಅದೇ ಕನ್ವರ್ಷನ್ನು ಹೆಂಗಾಗುತ್ತೆ? ಅಟ್ ಫಸ್ಟ್ ಎ ಈಸ್ ಗೆಟ್ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಟು ಸಿ, ಆಯಿತಾ? ಸಿ ಈಸ್ ಗೆಟ್ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಟು ಡಿ, ದೆನ್ ಡಿ ಈಸ್ ಗೆಟ್ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಟು ಬಿ. ಕನ್ವರ್ಷನ್ ಆಫ್ ಎ ಟು ಸಿ, ಇದನ್ನೇನಂತ ಕರೆಯೋಣ ನಾವು? ಎಂಥಾಲ್ಪಿ ಆಫ್ ರಿಯಾಕ್ಷನ್, ದಟ್ ಈಸ್ ಡೆಲ್ಟಾ H1 ಅಂತ ತಗೊಳ್ಳೋಣ. ಆ್ಯಂಡ್ ದಿಸ್ ಈಸ್ ಡೆಲ್ಟಾ H2 and this is delta H3 ಅಂತ ತಗೊಳ್ಳೋಣ. This is delta H3 and the enthalpy of this reaction, conversion of A to B, enthalpy of this reaction is equal to the sum of the enthalpies of the intermediate reactions. Sum of the enthalpies of the intermediate reactions means conversion of A to C, conversion of C to D, conversion of D to A. Sum means here we should take enthalpy of reaction delta H1 plus delta H2 plus that is delta H3. So that means enthalpy of reaction, that means Hess's law of constant heat summation can also be stated as, ಇನ್ನೂ ಒಂಥರ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೊಡ್ಬೋದು. ಏನದು? if a reaction takes place in several steps, takes place in several steps, then the standard enthalpy of a reaction is the sum of the enthalpies of the intermediate reactions, which can be divided by the overall reaction at the same temperature. If a reaction takes place in several steps, here the conversion of A to C, C to D, D to B, several steps, then enthalpy of reaction, standard enthalpy of a reaction, standard enthalpy of a reaction is the sum of the enthalpies of the intermediate reaction. These are the intermediate reactions. Sum ಅಂತಂದ್ರೆ ಏನು ತಗೋಬೇಕು? delta H1 plus delta H2 and delta H3. Sum of the enthalpies of the intermediate reactions. Okay, this is the another statement of Hess's law. Okay, I will write that. If, let us write down the statement of Hess's law now. That is, if a reaction takes place in several steps, then the standard enthalpy of a reaction is the sum of standard enthalpies of intermediate reactions into which the overall reaction may be divided at the same temperature. Sum of the enthalpies of the intermediate reactions into which the overall reaction may be divided. This is the overall reaction may be divided at the same temperature. This is another statement for Hess's law of constant heat summation. So, what we have studied now? Hess's law of constant heat summation. What is that? Change in enthalpy is same whether the reaction is carried out in one step or in a series of steps. Next concept is lattice enthalpy. Mainly, the ionic compounds are crystalline solids. And it contains oppositely charged ions, like we know that cations and the anions. We can give the example like sodium chloride, and here it contains the ions like Na plus and Cl minus. So, what is this lattice enthalpy means? Lattice enthalpy means this is the energy released when 1 mole of crystalline solid is formed by the combination of oppositely charged ions in their gaseous state. So, lattice enthalpy means it is the energy released energy released when 1 mole of crystalline solid formed 1 mole of crystalline solid formed by the combination of oppositely charged ions. Oppositely charged ions in gaseous state. What is that? Energy released when 1 mole of crystalline solid formed by the combination of oppositely charged ions in the gaseous state. Oppositely charged ions means what? Cations and the anions. And combination of cations and anions, in which state it is? Gaseous state. When they combines together, it forms a 1 mole of crystalline solid. 1 mole of crystalline solid. That means that, let us take one example now. A plus, we know that it is a cation because it carries a positive charge, and B minus, it carries a negative charge, so it is an anion, and both are in which state? Gaseous state. When these two combines together, it forms a crystalline solid, which is in a solid form. When cations and anions in their gaseous state combines together, it forms a crystalline solid, ionic crystal. And during the formation of this crystalline solid, what is the energy released here? That energy is called as lattice enthalpy. That energy is called as lattice enthalpy. Let us consider a reaction now, like Na plus, that is a cation which is in a gaseous form, and Cl minus, which is in a gaseous form. Both combines together, it forms NaCl, that is a solid form. And what is the energy released here? That energy is called as a lattice enthalpy. That energy is called as a lattice enthalpy, and here energy is released means it is negative. You are going to get some kilojoules per mole. That is, let us take it as a minus Q kilojoule per mole. And we can also give one more statement. Let us reverse this reaction. No? If you reverse this reaction, NaCl solid, it get converted into Na plus, which is in a gaseous form, Cl minus, which is in a gaseous form, and what is the change in enthalpy? That minus is changes into plus. Okay, because we have reversed the equation. Now we can change the statement. The energy is released here, but positive sign means here we should write the energy is required. Now it is not released. Energy is required to separate completely 1 mole of crystalline solid into its ions in which state? Gaseous state. In gaseous state. the energy required to separate 1 mole of crystalline solid into its ions in which state? In gaseous state. So, that enthalpy is also called as a lattice enthalpy. If 1 mole of crystalline solid is formed from its ions, means energy is released. When 1 mole of crystalline solid dissociated into ions, means the energy is required. And here we should calculate the lattice enthalpy. So, in order to calculate or in order to determine the lattice enthalpy, we should construct a enthalpy diagram. That enthalpy diagram is called as a Born-Haber cycle. Okay, let us study in detail about the Born-Haber cycle now. Born-Haber cycle. Okay, next is Born-Haber cycle. Born-Haber cycle. Here, let us consider one of the reaction, sodium chloride, which is in a solid form. It is formed from its elements in the standard states. Formed from its elements means sodium elemental form, that is the solid. Chlorine, that is Cl2, which is in a gaseous form, and 1 Cl means here we should take half Cl2. And what is the change in enthalpy? This enthalpy is called as enthalpy of formation. Enthalpy of formation. What is that enthalpy of formation means? Enthalpy change produced when 1 mole of a compound formed from its elements in their standard states. Formed from its elements, this is the 1 mole of the compound formed from its elements like Na and Cl2 elements in the standard states, and what is the change in enthalpy is called as enthalpy of formation, is called as enthalpy of formation. And during this reaction, the change in enthalpy is minus 411.2 kilojoule per mole, minus 411.2 kilojoule per mole. Okay, look at the reaction now. Now, we should calculate the lattice enthalpy. So, lattice enthalpy means we know that lattice enthalpy here, we need a reaction Na plus which is in a gaseous form, Cl minus which is in a gaseous form, it get converted into NaCl which is in a solid form. This is called as a lattice enthalpy. And in this reaction, Na plus in the gaseous form, but here sodium is present in the elemental form. First we should convert that solid into gaseous form, and then Na gas, that from that we should remove 1 electron, then it get converted into its cation. We know that if 1 electron is removed, 1 electron remove ಮಾಡಿದ್ರೆ ಅದು ಕ್ಯಾಟಯಾನಿಕ್ ಫಾರಮ್ಗೆ ಬರುತ್ತೆ. ಈಗ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಏನು, ಈ ಸಾಲಿಡ್ ಇರೋದನ್ನ ನಾವು ಗೇಷಿಯಸ್ ಫಾರಮ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ, ಸಾಲಿಡ್ ಇರೋದನ್ನ ನಾವು ಗೇಷಿಯಸ್ ಫಾರಮ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು ಅಂತಂದರೆ Na should get converted into gas. So, Na should get converted into gas means, so here I am going to write Na which is in the solid form, it get converted into gaseous form, and this process is called as sublimation process, solid to gas, and the change in enthalpy is called as enthalpy of sublimation, So, solid form is get converted into gaseous form. The enthalpy of sublimation is 108.4 kilojoule per mole. 108.4 kilojoule per mole, and here energy is required. Energy is required means it is one of the endothermic process, so the value is positive. So sodium solid is get converted into gaseous form, and what is the enthalpy here? That enthalpy is called as a enthalpy of sublimation. Okay, next step, from the gaseous sodium atom, an electron is removed. An electron is removed from the isolated neutral gaseous atom. It requires energy. What is the energy required here? That energy is called as ionization energy. So here sodium which is in a gaseous form, it get converted into its cationic form by the loss of electron. So here an electron is removed, that means it requires energy. What is the energy required here is called as a ionization energy. So enthalpy change here is called as enthalpy of ionization energy, and the value is plus 495.6 kilojoule per mole. Plus 495.6 kilojoule per mole. Once again energy is required here. So here Na is get converted into Na plus, and the enthalpy of ionization is here, it is 495.6 kilojoules. In the next step, Cl2, which is in a molecular form, and in the next step we should convert this Cl2 molecular form into atomic form. That means dissociation of chlorine molecule. So dissociation of chlorine molecule means dissociation of, so next step is dissociation of chlorine molecule. It dissociate into chlorine atom, and what is the change in enthalpy here is called as dissociation enthalpy, half Cl2. So here we should take half dissociation enthalpy, and the value is plus 121 kilojoule per mole. The value is plus 121 kilojoule per mole. That dissociation enthalpy. Molecule is dissociated into atomic hydrogen. So here let us write down Cl, gaseous form, and the change in enthalpy is called as dissociation enthalpy, and for the required equation Cl minus, that chlorine atomic hydrogen should get converted into its anionic form. So how it get converted into anion? Cations are formed by the loss of electron. Alva, one electron remove adre cation agate. Ade tara electron add adre anion agate. Illenagate next step alli chlorine gains an electron and it get converted into Cl minus. Anionic form ಗೆ ಬಂತು. ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಆಗಿದೆ ಅಂತಂದರೆ ದಟ್ ಈಸ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಫಿನಿಟಿ ಅಥವಾ ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನಿಂಗ್ ಅಂತ ಕೂಡ ಕರಿತೀವಿ. ಆ್ಯಂಡ್ ಹಿಯರ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಆದಾಗ ಆಲ್ವೇಸ್ ಎನರ್ಜಿ ಈಸ್ ರಿಲೀಸ್ಡ್. ಎಷ್ಟು ರಿಲೀಸ್ ಆಗ್ತಾ ಇದೆ? ಮೈನಸ್ 348.6 ಕಿಲೋಜೌಲ್ ಪರ್ ಮೋಲ್. ನೋಡಿ, minus 348.6 kilojoule per mole. So this is called as enthalpy of electron affinity or electron gaining, and here the energy is released. Look at the equations now. Here plus plus plus, all the three equations means takes place with the absorption of heat. but here the energy is released. So, that is why the sign is minus 348.6 kilojoule per mole. And here ನಮ್ಮ ಹತ್ರ ಈಗ Na ಪ್ಲಸ್ಸು ಗೇಷಿಯಸ್ ಫಾರಮಲ್ಲಿದೆ, Cl ಮೈನಸ್ಸು ಗೇಷಿಯಸ್ ಫಾರಮಲ್ಲಿದೆ ಅಲ್ವಾ. ಇದೆರಡು ಕಂಬೈನ್ ಆಯಿತು ಅಂತಂದರೆ ನಿಮ್ಗೆ ಏನು ಬರುತ್ತೆ, ವಾಟ್ ಯು ವಿಲ್ ಗೆಟ್ NaCl ಬರುತ್ತೆ. That means it get converted into crystalline solid. And during this reaction, what is the change in enthalpy? Alva? That enthalpy is called as a lattice enthalpy. ಅದನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ, lattice enthalpy ಅಂತ ನಾವು ಕರಿತೀವಿ. Lattice enthalpy means energy released when 1 mole of crystalline solid formed by the combination of oppositely charged ions in their gaseous state. So, one more definition we can also give. ಅದಕ್ಕೆ ರಿವರ್ಸ್ ತಗೊಂಡ್ರೆ ದಟ್ ಮೀನ್ಸ್ ಎನರ್ಜಿ ರಿಲೀಸ್ಡ್ ಬದಲು ಏನು ತಗೋಬೇಕು, ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಡ್ ಅಂತ ತಗೋಬೇಕು. ಕಾಂಬಿನೇಷನ್ ಬದಲು ಏನು ತಗೋಬೇಕು, ಸಪರೇಟ್ ಅಂತ ತಗೋಬೇಕು. ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಡ್ ಟು ಸಪರೇಟ್ 1 mole of crystalline solid into its ions in their gaseous state. ಸೊ ಇವಾಗ ಇಷ್ಟು ರಿಯಾಕ್ಷನ್ಸು ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. Now we should calculate the lattice enthalpy. ಈಗೇನು ಮಾಡೋಣ ನಾವು, let us apply the Hess's law. ಈಗೇನು ಮಾಡ್ಕೊಳ್ಳೋಣ, Hess's law ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳೋಣ. Hess's lawನಲ್ಲಿ ಏನು ಹೇಳಿದ್ವಿ ನಾವು, if a reaction takes place in several steps, then standard enthalpy of a reaction is the sum of the enthalpies of the intermediate reactions ಅಂತ ಹೇಳಿದ್ವಿ. Sum of the enthalpies of the intermediate reactions. These are the intermediate reactions. ಇದಿಷ್ಟೂ ಸಮ್ ಮಾಡಿಕೊಂಡ್ರೆ ನಿಮಗೆ ಓವರ್ ಆಲ್ ರಿಯಾಕ್ಷನ್ ಎಂಥಾಲ್ಪಿ ಸೇಮ್ ಬರುತ್ತೆ, ಅದೇ ಬರುತ್ತೆ ಅಲ್ವಾ. ಲೆಟ್ ಅಸ್ ಟೇಕ್ ದಿಸ್ ಆಸ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಫಾರ್ಮೇಷನ್, ದಟ್ ಇಸ್ ಡೆಲ್ಟಾ HF is equal to sum of the intermediate enthalpies of intermediate reactions ಅಂತಂದರೆ ಏನೇನಿದೆ ಬರ್ಕೊಂಡು ಹೋಗೋಣ. ಡೆಲ್ಟಾ H sublimation plus, that is ionization enthalpy plus here we should take half. Actually 242 ಬರುತ್ತೆ, ಹಾಫ್ ಮಾಡ್ಕೊಂಡಾಗ ನಮಗೆ 121 ಬರುತ್ತೆ. ಇಲ್ಲಿದೆ, that is half dissociation enthalpy plus ಏನಿದೆ, that is electron gaining enthalpy plus ಏನು ಬರುತ್ತೆ ನಿಮಗೆ, ಪ್ಲಸ್ ಯು ಹ್ಯಾವ್, ಓಕೆ ಐ ವಿಲ್ ರೈಟ್ ಒನ್ಸ್ ಅಗೇನ್, ದಟ್ ಈಸ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಫಾರ್ಮೇಷನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಂಥಾಲ್ಪಿ ಆಫ್ ಸಬ್ಲಿಮೇಷನ್, ಎಂಥಾಲ್ಪಿ ಆಫ್ ಅಯೋನೈಸೇಷನ್, ಎಂಥಾಲ್ಪಿ ಆಫ್ ಡಿಸೋಸಿಯೇಷನ್ and enthalpy of electron affinity plus lattice enthalpy plus lattice enthalpy. Let us substitute all the values. ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಎಂಥಾಲ್ಪಿ ಆಫ್ ಫಾರ್ಮೇಷನ್ ಗೊತ್ತು ನಮಗೆ. ವಾಟ್ ಈಸ್ ದ್ಯಾಟ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಫಾರ್ಮೇಷನ್ ಮೀನ್ಸ್, ವಾಟ್ ಈಸ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಫಾರ್ಮೇಷನ್, minus 411.2, and here sublimation is, now value is 108.4 plus ionization is 495.6 plus dissociation is 121, and here it is negative sign minus 348.6 plus it is lattice enthalpy plus lattice enthalpy, and it is minus 411.2. If you simplify this, you will get 787.6 plus lattice enthalpy, and we should calculate, if you add this, you will get the value. If you add this, you will get the value 376.4, and we should calculate lattice enthalpy, that is lattice enthalpy ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋಣ, minus 411.2 minus 376.4. So here you will get minus 87.6 kilojoule per mole. Round off ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮಗೆ if you round off this we will get minus 788 kilojoule per mole. Kilojoule per mole. Negative sign it is. Energy released when 1 mole of crystalline solid formed from its ions in the gaseous state. Suppose if the energy required to separate 1 mole of crystalline solid into its ions ಅಂತ ಅನ್ನುವಾಗ ನಾವು ಉಲ್ಟಾ ಬರ್ಕೋಬೇಕಾಗತ್ತೆ ರಿಯಾಕ್ಷನ್ ಅಂತಂದರೆ minus 788 ಇದ್ದದ್ದು ಏನಾಗುತ್ತೆ ಅವಾಗ plus 788 kilojoule per mole ಆಗುತ್ತೆ. Okay, this is about the Born-Haber cycle. Okay, I will write that here. For the dissociation of 1 mole of NaCl. 1 mole of NaCl means NaCl solid changes into Na plus gaseous form, Cl minus gaseous form, and the change in enthalpy is 788 but value ಏನಾಯ್ತು ಅಲ್ಲಿಗೆ ಪಾಸಿಟಿವ್ ಆಯಿತು plus 788 kilojoule per mole plus 788 kilojoule per mole. This is the amount of energy required when 1 mole of crystalline solid separate into its ions in their gaseous state. The value is plus 788 kilojoule per mole. If 1 mole of crystalline solid formed by its ions means the value is minus 788 kilojoule per mole. Okay, 1 mole of ionic solid is formed means always the lattice enthalpy is negative. If 1 mole of ionic compound dissociate into its ions means always the lattice enthalpy is positive sign. Okay, this is about the Born-Haber cycle. So here in the Born-Haber cycle we have used the Hess's law also. Next, let us take, by using this lattice enthalpy, we can also calculate the enthalpy of solution. We can also calculate enthalpy of solution. What is that? Enthalpy of solution means enthalpy change produced. Enthalpy of solution means enthalpy change produced when 1 mole of the substance dissolves in specified amount of the solvent. When 1 mole of the substance dissolves in specified amount of the solvent, what is the change in enthalpy here? That enthalpy is called as a enthalpy of solution. Enthalpy of solution. So this is the solid. When the substance dissolves in specified amount of solvent, it dissociates A plus and B minus, and this is called as a enthalpy of solution. Enthalpy of solution. And here the reaction takes place in several steps, like the AB solid, crystalline solid, at first it dissociates into A plus and B minus. A plus and B minus. 1 mole of the crystalline solid separate completely into its ions in their gaseous state. So what is that? What is the enthalpy change occurs here? That enthalpy is called as a lattice enthalpy. ಈಗ ತಾನೇ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ನಾವು ಅದನ್ನು. 1 mole of ionic compound ಸಪ್ರೇಟ್ ಆಗಿ ಗೇಷಿಯಸ್ ಅಯಾನ್ಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿದೆ. ಅದು ಗೇಷಿಯಸ್ ಅಯಾನ್ಸ್ ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ? ಇಟ್ ಗೆಟ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು aqueous ions, and that is called as a enthalpy of hydration. Gaseous form ಇದ್ದು aqueous form ಬರುತ್ತೆ, ಅದನ್ನು ನಾವು enthalpy of hydration ಅಂತ ಕರಿತೀವಿ. Enthalpy of solution ಅಂದ್ರೇನು? When 1 mole of the substance dissolves completely in specified amount of the solvent. During that process, what is the change in enthalpy is called as a enthalpy of solution. ನನಗೆ enthalpy of solution ಬೇಕು ಈ ಪ್ರೋಸೆಸ್ದು, ಆದರೆ ಅದು ಸೀರೀಸ್ ಆಫ್ ಸೆವರಲ್ ಸ್ಟೆಪ್ಸು 2 ಸ್ಟೆಪ್ಸಲ್ಲಿ ಆಗುತ್ತೆ. ಯಾವುದು ಫಸ್ಟ್ ಸ್ಟೆಪ್ಪು? ಎ ಬಿ ಇದ್ದಿದ್ದು ಎ ಪ್ಲಸ್ ಬಿ ಮೈನಸ್ ಆಯಿತು, ಬಟ್ ಯಾವ ಫಾರಮ್ ಬಂತು? ಗೇಷಿಯಸ್ ಫಾರಮಿಗೆ ಬಂತು ಅಲ್ವಾ? ಅಲ್ಲಿ ಚೇಂಜ್ ಆಗುವಂಥ ಎಂಥಾಲ್ಪಿನ ಏನಂತ ಕರಿತೀವಿ? ಲ್ಯಾಟಿಸ್ ಎಂಥಾಲ್ಪಿ ಅಂತ ಕರಿತೀವಿ. ಇದೆರಡು ಕಂಬೈನ್ ಆದಾಗ ಅದೇನಾಗುತ್ತೆ? ಈ ಗೇಷಿಯಸ್ ಫಾರಮ್ ಇದ್ದಿದ್ದು ಎಕ್ವೆಸ್ ಫಾರಮ್ ಬರುತ್ತೆ, ಅದನ್ನು ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಅಂತ ಕರಿತೀವಿ. ದ್ಯಾಟ್ ಮೀನ್ಸ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಸೊಲ್ಯೂಷನ್ is equal to lattice enthalpy plus hydration enthalpy. ಇದೆರಡು ಕಂಬೈನ್ ಮಾಡ್ಕೋಬೋದು. ಮತ್ತೆ ನಾವು ಹೆಸಸ್ಲ ಅಪ್ಲೈ ಮಾಡ್ಕೊಂಡ್ವಿ. ಎಂಥಾಲ್ಪಿ ಆಫ್ ಸೊಲ್ಯೂಷನ್ನು, ಲ್ಯಾಟಿಸ್ ಎಂಥಾಲ್ಪಿ ಮತ್ತು ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ. ನನಗೆ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಬೇಕು. NaClನ ನಾವು ಒಂದು ಸ್ಪೆಸಿಫೈಡ್ ಅಮೌಂಟ್ ಆಫ್ ಸಾಲ್ವೆಂಟಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂತ ಬೇಕು ನನಗೆ. ಸೊ ಇಲ್ಲಿ ಲ್ಯಾಟಿಸ್ ಎಂಥಾಲ್ಪಿನ ನಾವು ಈಗ ತಾನೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ. ಈಗ ರಿಯಾಕ್ಷನ್ ನೋಡಿ, ರಿಯಾಕ್ಷನ್ ಏನಿದೆ? ಸಾಲಿಡ್ ಇದು 1 ಮೋಲ್ ಆಫ್ ಕಾಂಪೌಂಡು ಅಯಾನ್ಸಾಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇದೆ. 1 ಮೋಲ್ ಆಫ್ ಕ್ರಿಸ್ಟಲೈನ್ ಸಾಲಿಡ್ ಇಸ್ ಗೆಟ್ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಟು ಇಟ್ಸ್ ಅಯಾನ್ಸ್. ಸಪ್ರೇಟ್ ಆಗ್ತಾ ಇದೆ ಅಂತಂದರೆ ಎನರ್ಜಿ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಆಗಿರುತ್ತೆ. ಎನರ್ಜಿ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಅಂತಂತಂದರೆ ಯಾವ ವ್ಯಾಲ್ಯೂ ತೊಗೋಬೇಕು ನಾವು? ಪ್ಲಸ್ 788 ಕಿಲೋ ಜೌಲ್ಸ್ ತೊಗೋಬೇಕು. ಪ್ಲಸ್ 788 ಕಿಲೋ ಜೌಲ್ ಪರ್ ಮೋಲ್. ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿದು ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಪ್ಪ ಅಂತಂದರೆ ಮೈನಸ್ 784 ಕಿಲೋ ಜೌಲ್ ಪರ್ ಮೋಲ್ ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿದು. ನೀವು ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿಕೊಂಡ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ ವ್ಯಾಲ್ಯೂ? ಪ್ಲಸ್ 4 ಕಿಲೋ ಜೌಲ್ ಪರ್ ಮೋಲ್. ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಬರ್ತಾ ಇದೆ? ಪ್ಲಸ್ 4 ಕಿಲೋ ಜೌಲ್ ಪರ್ ಮೋಲ್. ಅಂತಂದರೆ ನೀವು 1 ಮೋಲ್ ಆಫ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ನ ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ, ಡಿಸೋಸಿಯೇಟ್ ಆದರೆ ಎಷ್ಟು ಚೇಂಜ್ ಆಗುತ್ತೆ ಎಂಥಾಲ್ಪಿ? ನಿಮಗೆ ಒಂದು ಲಿಟ್ಲ್ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ವಾಟ್ ಇಸ್ ದ್ಯಾಟ್? 4 ಕಿಲೋ ಜೌಲ್ ಪರ್ ಮೋಲ್. So enthalpy of solution can also be calculated by using the lattice enthalpy and by using this equation. Okay, this is about the Born-Haber cycle. So students, what we have learned today, mainly the Hess's law of constant heat summation and lattice enthalpy and Born-Haber cycle. Thank you.